Okay, I think what was confusing in class was I was actually telling you two things. I was telling you how do you do the calculation to convert from rectangular form to polar form, but I was also trying to explain to you kind of how does the inverse tangent function make sense. And it turns out you actually don't have to understand that second thing in order to do the calculation. So let me show you first how to do the calculation, which is very straightforward, and then afterwards, if you're interested, I can show you how inverse tangent makes sense. So, quick review. A vector is a displacement, and the rectangular form describes the displacement as a change in x and a change in y. So here, to get from the tail of the vector to the head, you're going over by 2 and up by 6. Here, you're going right by 2, down by 6. You can also describe that same direction and distance as a direction and distance. So the direction would be described by an angle. And the angle is always relative to 0 here, so that would be the angle. And then the distance is the length of that line. For this vector that's headed kind of right and down, I could describe the angle as a negative angle because it's wrapping clockwise from this 0 angle. Or I could describe that same direction as the angle that goes all the way around. And this version would be a negative angle, and this version would be a positive angle, but they both describe the same direction. Okay, so you remember from last year that tangent theta gives you that distance divided by this distance, which is slightly technically wrong, or rather it doesn't apply to all parts of the unit circle, but that's the part that's not important to understand for the calculation. So let's assume that that's true. All you need to do in order to figure out the angle that describes the direction you want to go in is you make a triangle, and then you treat the distances of the triangle as positive because they're distances. So here's what that looks like. I want to find this angle, but that doesn't make a convenient right triangle. So instead, let's make the right triangle this way. And that is convenient because I know this distance is 2 and this distance is 6 because that comes straight from my two components there. And I made this 2 because it's a distance. This tells me both distance and direction. I'm going left by 2. But if I just want to know the length here, the length is just 2. Okay, so I could find this angle here, or I could find this angle up here. I think it's most convenient for me to find this angle because this orange one's the one I really want to find. So if I want to find this purple angle, I should also call it theta. If I want to find this purple angle alpha here, I know that tangent of alpha equals 6 divided by 2. So what that means is if I want to find the alpha angle, I take the inverse tangent of both sides. 6 divided by 2 is 3. And that will tell me alpha. And that's approximately equal to, what was it? It was like 71.57, I believe. Let me just double check that. Yeah, that was right. Okay, but that's not the angle that describes my actual direction, because the angle that describes my direction has to be the angle that references the 0 direction here. So all I do is I take 180 degrees and I subtract that angle that I found, and that'll give me my new angle. So that's 108.43. So I can write part of my polar form. So the polar form is a distance and a direction, and so now I know my direction is 108.43 degrees. The distance is easy. The distance is Pythagorean theorem because I'm trying to find the length of that hypotenuse, which is the same as the length of the vector that I'm traveling along. So for vectors, you notate the length this way, and it's called magnitude. And it's just going to be a squared plus b squared. And just to clarify possible confusion, my variable a here is describing this distance. A with a little arrow on top describes the entire vector. So 6 squared is 36, negative 2 squared is 4, so that's 40. So the overall magnitude is root 40. So this would be the right way to write, well, in our class, this is the right way to write the polar form. This is a non-standard way of writing the polar form, but I think it's very clear, and it connects to something later on in complex numbers that's going to make a lot more sense. Okay, what about this other one? This other one, it's easy enough to make this be the triangle. I could find this angle directly. So this is distance 2, that's distance 6. So again, arctangent of 6 divided by 2 is going to be approximately 71.57. But that describes, again, kind of the absolute angle, not the direction we're going in. So the actual angle at 71 degrees is up this direction. If I'm wrapping clockwise, that's the angle negative 71.57. So I can write my b vector here in polar form as root 40, because the length is the same, and then angle of negative 71.57. And that's it.